we were working on a Lattice QCD implementation based on Kokkos. And this all started like 3 years ago. So some of you might remember from the 2023 Kokkos user group meeting, where I presented the initial results this is based on. And yeah, now we get some more funding and it's really getting momentum. Guess at the end, yeah. So let's. Okay. Good luck. Yeah. So we are looking at the staggered fermion formulation of Lattice QCD here, and we are timing one of the most used. Yeah. It says that the screen is flickering that much. Is it on the connectors projector side? Okay. Well, so yeah, what you basically can take from that is that we are having a 9-point stencil in a 4D space, and at each point there's a matrix vector multiplication, complex valued. And yeah, so, but you're here for Kokkos, so let's talk Kokkos and not physics. We're using 32-bit floating point values wrapped in Kokkos complex. For our vectors, we use a 5D view with 4 dynamic extents, and for the links connecting that, we have a 7D view. For an example, working set size of a volume of 32 to the power of 4, we allocate vectors and links in that size to have a ghost layer for communication, but that's not used in this talk. Then default execution space and MDRangePolicy rank 4, going from 1 to extend -1, and custom tiling. Because, yeah, as you heard, tiling is an issue. So, yeah, the default tiling is an issue. It gets its right sometimes. Yeah. So let's jump right into my performance plot. So this is on our Jedi system, the current top one in the green 500 list. It's a Grace Hopper. So this is on the GPU side. In blue, we have the default tiling. Also, below each node, there's an marking what the tiling actually is. At the bottom, we have our volume in working set size, as we use it in Lattice QCD, and on top, it's a conversion to numbers, or something you're more comfortable with, I guess. Yeah, and in green, we see the tiling I found works best in an extensive search, so it took very long to go through all the tilings. Yeah, and we get an about 10% improvement by choosing a different tiling than the default for bigger lattice sizes. For small ones, its default is working fine. So I guess, yeah, it's not always bad. So that's the older generation A100. So here the picture is basically the same. Yeah. Then we can take a look at the Grace CPU, and in sustained memory bandwidth region, we get a 12 to 13% increase with the different tiling. So at the end, we can look a bit more at the tilings if you have questions. And now to an older generation EPIC CPU we also have at the center. there we see a big improvement in if we choose a different tiling than the default. So yeah, I guess the message of this talk is tune your tilings. The default gets it right sometimes, but mostly not. Yeah. So yeah, I should mention thanks to my collaborators, especially Bartek and Aniket from Bonn. And yeah, here you see all the funding that got into the project. And that's basically it. And yeah, the project I'm funded on ends this summer. So if you're quick and have a nice job for me, just tell me. Thanks.
Thank you.